Okay, we have a very good integral today. We've got the integral of natural log x over 1 plus natural log x all squared dx. Okay, for this one I know two ways, or two very similar ways that you might want to consider one way. One would be integration by parts for this. I'm not sure exactly how that one would go, but I'm pretty sure that would work. Now, what I want to do instead though, I was interested in the fact when you have something squared in the denominator, it makes me think about using the reverse quotient rule on it. If we look at our quotient rule for the derivative of something like f over g, our formula for this is just going to be f prime g minus f g prime over g squared. So the thing I like about this problem is it's really not clear at all how it's going to work because yes, the denominator looks fine, we've got something squared, but the numerator looks nothing like the formula here. So at first you're kind of like, there's no way this is going to work. But what I like to do with these is kind of start with what we know and kind of use the formula. So we're starting with really this assumption that this part right here is going to be our g value. So we'll set g equal to 1 plus natural log x, and then at least that way our denominator is going to be fine. We've got our g squared. And then if we know g, then we can at least get a derivative on this. So we'll take a derivative, g prime, derivative of 1, 0. Derivative of natural log, that's just going to be 1 over x. So I'm looking at the formula trying to figure out how this is going to work. Let's think about maybe f g prime first. So f g prime, just plugging in 1 over x, we're looking at f times 1 over x. And it's kind of hard to see how we're going to get a natural log x out of this. We could kind of play with some different values. Like, what if f was equal to, we could do f is going to be equal to x ln x. So then when we plug that in here, x ln x times 1 over x, x's cancel and we get natural log x. Let's see what f prime is going to be if we do this. So then for this we're going to need product rule. Derivative of x is going to be 1, so we're going to have 1 times the second part ln x plus, keep the first part, derivative of the second one, 1 over x. So this is going to be ln x plus 1. So if we did out the whole formula, f prime g minus f g prime, just using everything we know, for f prime, we're going to have ln x plus 1. G is, here, I'll just reverse the order. ln x plus 1 minus f g prime, that's going to be this minus ln x. But if you multiply this out, you're going to have an ln x squared. You're going to have like a plus 1. Basically, when we put this all together, this is not going to work. It's not going to match ln x, so we need to try a different way. The other thing I thought about with this f of g prime value, like one way to at least get rid of we don't want a 1 over x in this thing at all. I could do f is 0. So if we have 0 times 1 over x, then this term becomes 0, and then maybe this is ln x. The only problem is if f is 0 and we take a derivative, f prime is 0, then the whole numerator is 0, the whole integral is 0. That's not really what we're looking for. We need to get this ln x somehow. So this was a little bit like guess and check, because what I was looking at was a nice value here would just be, what if f is equal to x? So if our f value is x, then when we multiply this together, x times 1 over x, we just get 1 for that. And the other part, we know we're already going to have an ln x because our g contains an ln x. So with this assumption, I'm going to set f equal to x, and then our derivative's easy, f prime, that's just going to be 1. So I'm looking at this whole numerator, f prime g minus f g prime, plugging everything in with our f prime being 1, then g is this, 1 plus ln x, then minus our f g prime, that's going to be x times g prime, 1 over x. And what's going to happen, x times 1 over x, this is going to be a 1 right here. So we're going to end up with 1 plus ln x minus 1, 1's cancel, and the whole numerator just becomes natural log of x. So this is going to work right here. Now we just need to kind of get back to put all the pieces together to figure out how this is going to work for our solution. So coming back to our problem here in the formula, everything we have over here on the right side, this is our quotient rule. We're saying this is the same thing as this, but this is inside of an integral. So we're integrating here on f g prime, but because we're integrating a derivative, we know what this is going to be. This is just going to be the same thing as f over g plus c. So at this point, we can jump right to our solution. We already know our f and g value. We know our f is going to be x. We know our g is 1 plus ln x. So for the solution of this, I'm just going to have x over 1 plus ln x, add a plus c, and that's it. Okay, there you go. Good one today with the reverse quotient rule. Thanks everyone for watching. Have a good day.